My name is Aurelio Garcia Ribeiro. I'm a Director of Product Management with Oracle for the Java Platform Group. And I'm going to tell you a little bit about Java SE 11 and some of the features that were introduced in this latest version. So first, I'll tell you about the release cadence. We've recently changed the way in which we release versions of Java. I'm going to talk about how this makes it more open and allows better communication with the community and the other contributors to Java. Then I'll tell you a little bit about what's new in Java SE 11, and I'll hand off to some of my colleagues to tell you the last part about what's happening after Java 11 and training and summary. So for the release cadence overview. We used to have a traditional model on which we produced a major version, and the goal was to have a major version approximately every 2 years. And then we would support it for a very long time, so you ended up with this very common looking schema for a roadmap. Now, if you paid close attention, at the beginning of those 2 years, when a release was the most current one, we had what we called minor updates. So if we had used the previous model, after releasing JDK 9, we would have come up with a 9.1, 9.2, 9.3, and then 6 months after that, 10, 10.1, 10.02, and so on and so forth. So you'll notice we were supposed to have an opportunity for releasing something new every 6 months or so. However, when you're talking about projects that last that long, that's not how it works out. You run into issues and you end up having to sometimes delay the next major version. So we had closer to 3 years rather than 2 between Java 8 and Java 9. Now, if we go back to the original intent, we thought we're already set up on paper to have a release every 6 months. But under the previous model, some of those releases had some constraints on what could go on. So you had the major features needed a change in the Java specification, and they could only go on the major releases. And then during the minor updates, you could improve here and there, but you were constrained. You couldn't change the spec, so you couldn't add new APIs. We thought, why don't we lift that constraint? And in order to do that, rather than having a major release, we're going to have feature releases. So every 6 months, we're going to have a new feature release. And this is not the same thing as a new major release every 6 months, because there's no way we can deliver the number of features that we used to deliver in one of those majors every 6 months. But the point is now we can deliver any change, a change in the spec, remove something, deprecate something on any one of these releases. Now, it wouldn't be possible for us to support all of these releases for a very long time like we did before. So we're going to borrow something that's being used by industry for operating systems and browsers. And some of those releases we're going to call LTS, or long-term support releases. And for those releases, we'll offer updates for a very long period, whereas the others get superseded by the release of the next one. The next question after that is, of course, well, how often are you going to have an LTS? Now, even though we were aiming for 2 years between releases, we've been averaging 3 years between major releases. So we've decided to try at first with, let's go with an LTS every 3 years. We've recently released JDK 11, which is the first long-term release under this new model. And we have another one scheduled 3 years after 11 with JDK 17, and so on and so forth. These changes are not retroactive. So all the commitments that we had for JDK 6, 7, and 8 remain as they were. There's another important change that happened here, which is we used to produce a binary called the Oracle JDK, which was mostly based on OpenJDK, but included some commercial features and some other functionality that was not available in OpenJDK. And we released that under a license called the Binary Code License, the BCL, which allowed you to use it on general purpose computers without having to pay a license fee to Oracle, as long as you complied with certain constraints of the license. Now, that meant that the Oracle JDK didn't quite match the code in OpenJDK. And that's pretty common, by the way. But now that we're going to have these releases happen so frequently, any differences between the binaries get very costly. So starting with JDK 9, we decided, you know what, we're going to try to match and not have any differences. Our goal is to have the binaries be exactly what you would get if you go and compile OpenJDK code. We weren't ready for JDK 9, so there was still some functionality that was available only in Oracle JDK that wasn't yet in OpenJDK. Weren't quite there either for JDK 10, but for JDK 11 and onwards, they're virtually interchangeable. There is no different capabilities or performance between OpenJDK and Oracle JDK. So that's one in functionality-wise. There's also another important change, which is licensing. As I said, we had this license called the binary code license, which worked for public usage and also worked for commercial usage. But it had some constraints that made it not ideal for either of those. So we decided, okay, why don't we use a more commonly used license for the open source version? And we've released the OpenJDK binaries under the GPL, which is an open source license that most people are familiar with from their downloads of Linux. Now that we have an OpenJDK binary under GPL, we can say, okay, the Oracle JDK then doesn't have to have this dual purpose license. Starting with JDK 11, when they match, we're going to offer the Oracle JDK only under a commercial license. So the Oracle JDK and the OpenJDK binaries, they have the same functionality, the same performance. The difference is Oracle JDK has support. So if you run into a problem, you can call Oracle. And it therefore requires that you license it from Oracle and you pay a fee for it. OpenJDK, on the other hand, it's the same quality, tested by the same people, but if you run into a problem, you'll have to go online and look for a solution. You can file a bug in OpenJDK and we'll address it, at the same priority as we would any other OpenJDK bug. Also, a big distinction is the availability of long-term support. As you can see from this graph, or slightly better if we put it in this format, the OpenJDK binaries, you get only the latest version. So there is no long-term availability for the OpenJDK binaries. As soon as JDK 12 comes out, we stop providing binaries for updates for JDK 11. Whereas if you stay on the Oracle JDK, we'll offer you long-term support and we'll offer releases for at least 8 years, which is the standard Oracle terms for support. So, making Java more open. This means, what I just said, that we expect most people will go from grabbing the Oracle JDK to using instead the OpenJDK built by Oracle, which is available at that URL jdk.java.net. When I said that there were some features that were not available before to the open version, but were available in Oracle, this is pretty much the list, right? We had application class data sharing, which we made open with the release of OpenJDK 10. It allows you to share some classes. It allows you to reduce the amount of memory that you use when you're running two processes that use the same classes. You have Project CGC, which never quite made it as a commercial product, but that's where it was going, and it instead has been included in OpenJDK 11 and onwards. Flight Recorder and its partner, Mission Control, allow you to monitor what the JVM is doing in production with very little overhead. And I'm going to touch upon those in a minute. Mission Control is, if you will, the player that allows you to play the recordings made by Flight Recorder. So Flight Recorder is the capability in the JVM for creating these logs, let's call it that. And Mission Control allows you to investigate them and see what was going on. And Usage Logger, which is the only thing that hasn't yet been made available to the community, which allows reporting how Java is being used in your system. So, what's new in Java SE 11? As I mentioned, Java SE 11 is no longer a major release. So unlike the hundreds of changes that came, say, in JDK 8 or JDK 9, 10 and 11 have a very small set when compared. When we started the planning for JDK 11, we only had, well, it says 3, it's actually 4 JEPs targeted, right? The ones in that list. And as we approached the release date, we increased that. We ended up delivering 17 JEPs. And that's a Java enhancement proposal. That's the unit of work that we use for delivery and functionality in the JDK. So what I was saying before, right? We had a much larger number of JEPs on JDK 8 and 9, the major releases, than we did with 10, 11, and 12, and that we expect in 12 and above. So some of the features that came with 11. JEP 330 allows you to launch a single source file program. So when you're writing a complex application, you're going to end up probably with dozens, if not hundreds, of classes. But when you're learning, most people just write a simple class. And then the overhead of having to compile it first and then run it decreases on the, it just breaks your rhythm when you're trying to learn this. So starting with JDK 11, you can just run without compiling the hello world.java class that you wrote. You can see a sample here. So, it takes an extra step, makes it more fluent. So JEP 321 introduced HTTP client to the JDK. And if you were paying attention, you may wonder, didn't we have HTTP 2 with JDK 9? In JDK 9, this was a incubator module, which meant we weren't sure it was ready to be used in a standard format. So we told people only use it if you're willing to have it change underneath you. Now with JDK 11, we feel that we've reached the point where we can just put this in the standard and have everybody use them in production without worrying that it might change in the next version. So it supports HTTP 2 and WebSockets. It's a standard thin client. We also introduced JEP 332 TLS 1.3, which is an overhaul of the protocol used for creating secure connections. Now, this is a poster child of what you can gain by using this new model on which we assign new features to a release much closer to when they're done. TLS 1.3, the standard, was approved only a month or so before the release of JDK 11. Now, under the old model, there was no way that a standard approved a month before a major release was going to make it into that release. It would have had to be delayed until the next one, so you would have seen it about 3.5 years after it was approved. In this case, it worked out perfectly, and JDK 11 offered support for a new set of security algorithms pretty much immediately. Another important enhancement is JEP 328, Java Flight Recorder. So this one is actually one of the more exciting ones. Oracle's JDK for over a decade now has had the capability of creating a very detailed profile of what the Java virtual machine was doing when running a program. So this was very useful for two cases. When you were developing an application, if you wanted to understand what was going on and you wanted to get some insight of how your code is being interpreted during runtime, this would have given you that insight. And perhaps more interestingly, when you're using this in production, it allows you to catch errors that are very hard to catch in development time. So say you have a problem that happens when some memory has been leaking for, 10 days. You're not going to find that while running in your IDE because you're not going to have this thing running 10 days. So normally you would find this because something blows up in production. And the team that's running this would just restart the machine and then tell the developer, hey, something went wrong, can you fix it? And you've lost all of the information that you would have needed to debug this. If you have Flight Recorder on the other hand, when something like this happens, Flight Recorder is continuously writing in a circular memory buffer, and when something goes bad, it'll just save that and allows that to be handed over to the developers so that they can, at a separate time in different machine, debug it and figure out what went wrong. So this has been used for support within Oracle products very successfully for a long time. But before JDK 11, it was a commercial feature. Starting with JDK 11, it is now available to any member of the community, and we expect that it'll grow with more contributors as well. We also introduced CGC. This is, by the way, an experimental feature in JDK 11, so there might be some further changes to it, but we've already received some fantastic feedback on this. It allows you to handle multi-terabyte heaps and have very small and, I won't say deterministic, but probabilistically very unlikely that you'll have GC pulses that are larger than, say, 10 milliseconds. And as you can see here, there's a minor, whenever you start to trade off, I don't want more pulse times, you usually get hit with a reduction in throughput. But this is a pretty manageable 15% for that 10 millisecond pulse times. So this is pretty exciting. And what's more, this is the foundation. So this will get better over time. This is an example of that. If you want to go take a look at these numbers, the first one, the one on the top left, that gives you the throughput, right? And you can see that CGC is comparable to parallel and G1. However, the pulse times are much smaller with CGC. Notice the last one, the scale is logarithmic, so it's even more impressive than it looks like at first sight. So you should take this for a spin. And at this point, I'm going to hand off the presentation to two of my colleagues. Nick Rustiga is going to continue with a couple more of the JEPs that are available in JDK 11.
Thank you, Aurelio. This is Nick. I'm a curriculum developer and game designer with Oracle University. In part 2, we'll take a look at 2 more JEPs, but in more detail. These topics are tested on Oracle's professional certification exams, the idea being that if you become Oracle certified, you can go to a company and confidently say, hey, I know what I'm doing. I'm an Oracle certified professional. I believe I'm qualified for this job, this promotion, whatever the case may be. A Java 11 certified professional, the expectation is that you should be able to create variables using local variable type inference and create Lambda expressions with type-inferred local variables as Lambda parameters. JEP 286, local variable type inference, was introduced as of JDK 10. Previously, all local variable declarations required an explicit type on the left-hand side. In this example, byte array output stream. You can see it on both the left and the right side. It's quite a bit of typing, though. Now, the explicit type can be replaced by the reserved type name var. The compiler infers the variable type from the initializer on the right-hand side. Why is this helpful? Take a look at this example. This code reads a line of text from a socket using try with resources. The networking and I/O APIs use an object wrapper idiom. Each intermediate object is declared as a resource variable so that it will be closed properly if an error occurs while opening a subsequent wrapper. The conventional code for this requires the name of the class to be repeated on both the left and right-hand sides of the variable declaration. So in this case, input stream reader, buffered reader, but the result is a bit cluttery. With local variable type inference, that noise is reduced considerably, and as a result, variable names align, making your code more readable, and class names aren't repeated, making your code more concise. What do we mean by reserved type name? I want to explain this by comparing it to keywords. We know that keywords can't be used for variable names, but var is not a keyword. So if your old code happened to use var as a variable name, it won't break under Java 11. It's just not a recommended name because it's not all that descriptive. Instead, by reserved type name, we mean that var for type inference is only used when we know we're looking for type information. Where can this be used? With local variables, where the type can be inferred from the initial value. As enhanced for loop indices, traditional for loop index variables, and with some non-denotable types. Non-denotable meaning types that can exist in your program where there's no explicit way to write the name of that type, such as intersection types, for example, if you needed to infer a non-explicit type that, if it existed, would sit at the intersection of 2 other types. Or anonymous class types, for example, to declare a singleton instance of a local class to let the compiler infer the proper reference type to access the unique fields and methods within an anonymous inner class. Where can it not be used? It can't be used in declarations without an initial value, or in initializations with a null value, compound declarations, array initializers, fields, parameters, or as a method return type. Well, why not? Consider this bad example method. Public var get something. It has a var something parameter, and then it returns something. So what kind of argument can be passed into this method? What exactly is the return type? How should this compile? Because something could be anything. Type inference is an algorithm, not magic. A goal of this feature is to let developers more quickly read and understand code. But to achieve that understanding, both humans and the compiler require context. Now, could you argue that you could infer what something is based on code elsewhere? Let's say that this method is being called and an object of type A is used as an argument. Can we safely infer the type of something? Not quite, because what's to stop code from elsewhere from passing in an object of type B? Another goal of this feature is to prevent action at a distance issues. Don't allow code elsewhere to conflict on what type to infer. This prevents binary incompatibilities. Type must be inferred where the variable is declared. Now, there's a bit of debate around this feature. People against it will argue this feature is bad because useful information is being hidden. Readability is being impaired, and bad developers will misuse and overuse the feature to write terrible code. Arguments in favor of this feature say, I think this is great because redundant information is removed, code is more concise and more readable, and don't worry about catering to the bad developers. Bad developers will write terrible code no matter what. So who's right? Well, this feature, like many others, must be used with good judgment. And there are guidelines you can use to more effectively realize the benefits of this feature. Guideline 1. Choose a variable name that provides useful information. This was always a best practice, but it's even more important now. Consider names that express the variable's role or nature. Result isn't all that informative of a variable name. We can tell from the context that result is going to be a stream of customer objects, but that context goes away when we use var. So a more informative name for the variable would be customers, for example. Also, consider names that convey the variable's meaning or type. X for the list of customers, again, isn't all that informative. Change that to cust_list, that's a better name. Guideline 2. Minimize the scope of local variables. In this example, we have an array list, and we're adding an item to it that's intended to be processed last. Now, this works, but what if we later realize we need to change the list to a set? A bug is going to occur because set has no defined iteration order. Now, the issue is easy to assess when all the pertinent code is very close. But let's say we have 100 lines of code between where our hash set is created and where we add an item. Because they're so far away, it becomes harder to read and harder to assess the situation. Guideline 3. Consider var when the initializer provides sufficient information. Here, both sides of these statements offer type information. Byte array output stream, buffered reader, list. We can see those written on both the left and right-hand side. The constructor or factory method calls should provide enough context. So, change the left-hand side to var. Our code becomes much more concise, much more readable. Guideline 4. Consider var to split chained or nested expressions. The examples we'll look at will take a collection of strings and finds which occurs most. As a single expression, it's hard to decipher the stream and optional mix. It looks like a single stream pipeline, but in fact, it's a short stream followed by a second stream over the result of the first, followed by a mapping of the optional result of the second stream. If you split it, splitting may yield a good balance of readability and concision. Guideline 5. Don't worry too much about programming to the interface with local variables. A common Java idiom is to construct an instance with a concrete initializer type, but assign it to a variable of an interface type. Binding the code to the abstraction, in this case the list, instead of the implementation, in this example the array list, offers flexibility to change the initializer type with minimal complications. But this isn't possible when working with local variable type inference. Var list equals new array list string. This is going to be inferred as an array list, not a list. But potential issues can be easily avoided or mitigated because list is a local variable whose scope should be extremely limited. That's what Guideline 2 was all about. Guideline 6, take care using var with diamond or generic methods. Consider this statement. Priority queue of item objects, item queue equals new priority queue of items. The diamond feature lets you omit explicit type information, as you can see on the right-hand side. Var also lets you omit explicit type information, as you can see on the left-hand side. But if you combine both, it strips the statement of context. As a result, item queue is inferred as priority queue of objects, which may not be that helpful. What you can do, though, is have some arguments, which can provide context so type is inferred properly. Here we have a comparator of string objects comp. Then we can pass that into the priority queue constructor. And as a result, item queue is inferred as priority queue of string objects. Finally, Guideline 7. Take care using var with literals. There's no issue with Boolean character long or string literals. The issue occurs when you're working with whole numbers. If you're not careful, your whole number may be inadvertently inferred as an integer type. Take a look at the first example. Byte flags equals 0. How do we know that we intend 0 to be a byte? Because we're declaring that variable flags to be a byte. Whereas if you use var flags equals 0, there's no information here to say we intend to save this as a byte. The situation is similar with shorts and longs. At least in the case of a long, but we at least have the option of writing 17L. That'll provide enough context for the compiler to know that base is meant to be a long, not an int. Floating point numbers require similar care. Just be sure that if you mean to save your variable as a float, use the little f for context. Otherwise, it'll be saved off as a double. You could also cast in all these situations, but that's contrary to the goal of being concise. The last JEP we'll cover is JEP 323. Local variable syntax for Lambda parameters. Previously, Lambda expressions could be explicitly typed. They could also be implicitly typed. But now, Lambda expressions can also be implicitly typed using the var syntax. What are the benefits of this? Well, the obvious benefit is that it gives you uniform syntax for local variable type inference. Everywhere you look, it can be done using var. A more interesting benefit in the context of Lambda expressions are the use of annotations and modifiers. Previously, these required explicitly typed lambdas. There was no shorthand version for this. Now, var provides a more readable, implicitly typed alternative. Just a few words of caution, though. These examples won't compile. Previously, you could never mix implicitly and explicitly typed lambda parameters. And the same is true now with var. You can't mix var and non-var implicitly typed lambda expressions, and you can't mix var and non-var in explicitly typed lambda expressions. And just like lambda expressions that have a single explicitly typed parameter that requires parentheses, the same is true about var parameters. Neither can omit parentheses. And that's it. Study hard, get some good Java 11 experience under your belt, and you should be ready for the certification exam.
Thanks, Nick. So let's have a look at what's going to happen after Java 11. So some of the big challenges or opportunities that we have in front of us include things like making sure that Java runs really well in containers. Containers are becoming very prevalent in deployments today. We are constantly looking at how we can improve on predictability and make sure that Java runs really well and in a predictable way. Performance has always been very, very important for us, and that's something that we like to stay on top of, and we will continue to invest in that and make sure that new features as they come in through processors, and that we start leveraging them and making sure that Java runs really fast. One of the things that we've started looking into more recently, and that is becoming more important in our industry, is data optimization. So code we've been looking at for quite a while, and now we're looking at new areas, and those include things like data. So I'll go into, in a few minutes, some of the specific things we're looking into there. Hardware, we are looking into new types of hardware, new devices, new instructions in the CPUs, and making sure that we leverage those and make sure that Java really leverages the acceleration that we get out of those features. Scalability, which is a variant of performance, is obviously important as well. We want to make sure that Java can leverage many CPUs, a lot of memory, and run really well without you having to tune things manually. And of course, we're always looking into how we can improve the Java language by introducing new features and new constructs to make it easier to write code, and perhaps more importantly, read code, which is obviously what you do more of. So looking at some of the specific projects we have around this, so with the new release model, we now have a Java that is moving forward in a faster and more predictable way than ever before. So this release model has us now delivering a feature release every 6 months. And as part of introducing this new model, we've also had to make some changes to the development process in the background. We obviously want to make